I say simplify a radical. It's the idea of taking, and we'll start with a perfect square. We're going to actually list some in just a minute. Now, I don't always put the little shelf there, if y'all know what I'm talking about. Technically, the radical itself, I didn't do a good job, it kind of has that little check mark on the front of it. And I don't always put that little. Sometimes I just kind of put the V-shaped and don't go any further. But I'm going to try to draw a decent one here. And hopefully you know that if we're just dealing with positive numbers, which usually in geometry, you're dealing with distances and things like that with square root, and we don't do negatives. So the principal square root of 16 is 4. I think you know that because 4 times 4 is 16. Now let's talk about the parts. This thing right here is the radical. And the number underneath it is called the radicand. Now, this is not something, y'all know, I don't ask you to memorize it, but it's just one of those things, if you hear a teacher mention it, you at least know you've heard of it. Now, if there's not a number here, I'm going to put like a circle there, and that will be what's called the index or the root. Now, if there's nothing there, it's understood to be square root. It's like an X with nothing in front of it has an understood 1. A radical with no number right there is square root. But if you have another number, and we just did this in Algebra 2 yesterday, if you have like your square root symbol and a little 3 there, I'll do that one. That means like the cube root of 8, which the cube root of 8 is 2 because 2 times 2 times 2 is 8. We're not doing cube root. That's the reason when I say simplify radicals, you could technically be doing all roots. Cube root, fourth root, fifth root, that type of thing. We dabble in this in Algebra 2, but I just went back and changed it to square roots because that's the root we're doing rather than cube root or fourth root. But see the difference. If there's nothing there, it means square root. The index is understood to be 2 if, I'll put that in quotes like that, if no number. So if there's not a number there, it's understood to be square root. So that makes sense. Now let's talk about perfect squares. Let's see how far y'all can name them. The easiest way to find your perfect squares, start with 1. 1 squared is 1 because 1 times 1 is 1. That's a perfect square. What's the next one? 4. See, like the 16. So if you'll think about it, if you go 1 times 1 is 1, 2 times 2 is 2, 3 times 3 is 9, 16, 25, keep going. 36, I'm going to go up here because we're going to list them. See how far you can list them. Let's see, that's 6. 7 is 49. 8 is 9. 81. I'll start right 91. 10. 11. 121. 12. And most people, that's as far as they go. 13 is 169. 14, I always try to do it myself because it helps my brain from getting rusty. Let's see, that's 13. 14. 15 is 225. 16 is, I should know that one. I think it's, yeah, 256. I didn't remember that one. That's as far as I know them. Now, there's some special ones that you might recognize, like 400 would be. What would be the square root of 400? 20 times 20 is 400. Very good. Another one is 625. That's one sometimes they use it because it's 25. 25 times 25 is 625. Now, a couple of things that we use when we're doing this. What is the pattern of what's going on when I say what's the square root of 4 squared? Because really what it all comes down to is, do you have to have a calculator to do this? Now, if you want to think about the square root of 4 squared as being the square root of 16, the answer is 4, right? But I want you to look for a pattern because this is going to come up in what we're doing. And what would be the square root of, let's do, I did 10 squared. Let's do that one. That's the square root of 100, which is 10. Now, if you see the pattern, you should know the square root of 52 squared. Now, do I have to take my calculator and square it square 52, and then take the square root of it to know the answer. What should the square root of 52 squared be? 52. So I don't know what 52 squared is. I don't really care what 52 squared is. But that's an important fact that you need to know when we do perfect squares. The way I teach simplifying square roots is what we call prime factorization. You know that's just a fancy name for factor trees. Except I tend to do, with numbers, I tend to do upside down birthday cake. Does that ring a bell with you? Do you know what that is? Prime factorization is, the simple name is it's called a product of, you can say a product of prime numbers. I just say a product of primes. So you got to know what product means. What does product mean? What operation? Multiplication. And then we're going to multiply prime numbers. Well, what's a prime number? Oh, these things come back to us. We haven't done them in a long time, have we? What's a prime number? I'll give you a little bit of hint. It has only, before I talk about it, what do we mean by factors of something, and what do we mean by their factor pairs, that type of thing? What are the factors of 6? What are the numbers that go into 6? 1, 2, 3, and 6. Now the factor pairs are 1 and 6, 1 times 6 and 2 times 3. So it uses the same concept. That is not a prime number. It's a composite number. Now every number, starting with your natural numbers, your counting numbers, starting with 1, every one of them is either prime or composite except for one of those numbers. Every number, 20 is composite, 17 is prime. So what's splitting those? What does a prime number only have? We just talked about them. It has how many factors? Be careful. 2 factors, which are 1 and itself. So let's see if you can name. What's the first prime number? What's the first number that has only 2 factors? 2, 3, 5. See if you can name them. Help Liam out. He's not the only one that knows them. Okay, but 7. Did you say 7? 11, 13, 15. See, 3 and 5. You got to remember. So it's not all odd numbers. See, you have to be careful on that too. 17, 19. I'm just going to put ... They get further apart, obviously, the further you get when you start naming them. And all the other numbers are composite except for 2 is the only even prime number. And because think about it, 4's 3 factors are 1, 2, and 4. See, if it's an even number, it's going to have 2 go into it. So if it's an even number, 52, I know it's got to be composite because 2 goes into it. And 1 is the only, 1 is neither, let's say it that way. Why would it not be prime? How do you spell neither? Is it I-E or E-I? It's E-I in it, yeah. Neither prime nor composite. Why is it not prime? It only has 1 factor, that's right. Okay, so 1 is neither, 2 is prime, and then you just start naming them from there. Okay, let's just jump into it.